This is lesson 16, parallel lines and the angles in a triangle. And this is activity 2, angle plus 2. So we're going to have an angle and we're going to add 2 more triangles to that. I'm skipping activity 1, which was just some computation practice. All right, so for activity 2, what they ask you to do is to look at this triangle, and we're going to rotate this triangle 180 degrees. And 2 of the sides of the triangle are not do not have the center of rotation on them. So this is the center of rotation here, and it's not on this side of this triangle here, and it's not on this side of this triangle here. It is on this side. So 180 degree rotation. Let's deal with the first one, the easy one first. A is going to rotate 180 degrees and end up where C is, and C is going to rotate 180 degrees and end up where A is. But if you remember from previous lessons, a line that's rotated around 180 degrees is going to end up on the other side, an equal distance on the other side and parallel to this line. So this line is going to rotate 180 degrees over here, and it's going to end up right here. It's going to be parallel, it goes over to, it's going to be parallel to this line. This line segment is going to rotate 180 degrees and end up right here. And it will be parallel. So it's going to go up here, and it's going to be parallel. It's going to go out to about right there. So 180 degrees around this center of rotation. So if we look at that, to figure out where D goes, D is the corresponding point to B. And so B is going to rotate 180 degrees around and end up where D is. And you can figure out where it goes a couple different ways. Maybe one of the easiest ways is just by counting. So I'm going to count to the left, 1, 2, 3, 4, and count down 1. So that gets me to B. So then I'm going to change the sign, both signs of that count. So I'm going to count up 1, so a positive direction of 1, and to the right 4 units, 1, 2, 3, 4. And that places D right here. Another way to look at it is D is an equal distance from the center of rotation on the opposite side of B. So you go through the center of rotation because it's a 180 degree rotation. You go right through the center, and D is on the opposite side, an equal distance away. Same with the triangle. If we rotate this triangle around this center point between the midpoint of A and B. So now we're going to rotate the same triangle, but we're going to rotate it in the opposite direction. So I can't remember what the directions say, whether it says counterclockwise or clockwise. Rotate triangle around midpoint side. Actually, it doesn't make a difference. You're going to rotate 180 degrees, you're going to end up in the same place, whether you go clockwise or counterclockwise. All right, so E is going to end up in the opposite the center of rotation, an equal distance from the center of rotation that C is on this side. So E, to get to E, one way to do that is to count. So I'm going to count down 1, 1, 2, 3, 4, 5, and to the right 5. So I'm going to rotate 180 degrees around and do the opposite count. I'm going to count up 1 and to the left 1, 2, 3, 4, 5. So that gets me to E. And notice that I could draw a straight line from E through the center of rotation to C. And they are an equal distance opposite that center of rotation. All right, we've gone through that before. So now what happens to these angles? This is what we did last lesson. This angle here, angle EAB, angle BAC, so BAC, and angle CAD. They land on a straight line. So how many degrees do they add up to? It's half of a circle, so it's 180 degrees. And the last part of this is, do you see angles in triangle ABC that are equal to angle EAB? And of course you do. This is an alternate interior angle. If this angle rotates 180 degrees around this center of rotation, it's going to land right here. It's an alternate interior angle, so that angle is going to be right here. And so these two angles are equal because it is a rotation. So if you take an angle through a rigid transformation, in this case a rotation, it remains congruent, it remains equal. And this angle here is likewise, it's going to rotate 180 degrees, it's going to rotate down here, and it's going to land right here. So the opposite side of the center of rotation, so it rotates 180 degrees and ends up right there, and it is congruent. So these three angles are equal to these same three angles. So what do these three angles all add up to? They'd add up to 180 degrees. And so it's another way of demonstrating that the sum of the angles of a triangle equal 180 degrees. This is exactly the same thing that we did last lesson, where we tore these, or we cut these apart and formed a triangle. So you can imagine cutting these three angles out, putting this angle down here, putting this angle down here, and you end up with this, in this case, a congruent triangle. We were ending up with similar triangles before, but this triangle would be exactly the same. All right, so that's lesson 16.2, lesson 16, activity 2, an angle plus 2. So one angle plus two more, two triangles, or two more angles.